Hello friends, this is Maurya. Today I am going to demonstrate NIC bonding in RHEL 6. What is NIC bonding? Why we use NIC bonding? What is the advantage of NIC bonding? So you will learn everything about NIC bonding in RHEL 6. Let's start. NIC bonding is an aggregation of multiple NIC network interface card into a single interface called NIC bonding, or it is known as NIC teaming also. Basically, it's a kernel feature and also known as NIC teaming. It is used basically to provide high availability and load balancing services. Means if we are using single network interface card, in case if something goes wrong from network interface card's end, so we lost connectivity in case if any application or database is running on the server. So we use NIC bonding to avoid any connectivity failure and to enhance the data throughput, I mean over the network interface card. So basically that's why we say it provides high availability and load balancing services. So we'll move ahead. In order to configure NIC bonding in RHCSA 6, we should first check the prerequisite of NIC bonding. Number one, bonding module must be loaded in the kernel. As I said, NIC bonding is the kernel feature, so it must be loaded into kernel module. Second, there must be at least two network interface card connected on the server, because minimum two NIC network interface card is mandatory to configure NIC bonding. So let's start. Number one, bonding module must be loaded in the kernel. For this we need to check with the command mode info bonding, which gives an output whether bonding is loaded into the kernel or not. In case if bonding module is not loaded, then load it using below commands. Means here is the command. Don't take me otherwise, because I have already prepared the all the topics in a notepad plus plus. I'm demonstrating here. We'll move ahead after discussing these points to do a practical session. So if it's not loaded, we need to run this command mode prof space bonding. After that we will again verify whether bonding module has been loaded into the kernel or not. Number two, there must be at least two network interface card connected on the server. For this we would check using ls space sys/sys/class/net. It will list down all those available network interface cards. So let's start a practical session. First we will check whether bonding module has been loaded into the kernel or not. Let's say mode info bonding. Here you can see bonding module has been loaded into the kernel. Next we'll check availability of the NIC network interface card sys class net. Here you can check all those available NIC cards. So let's start the configuration part. cd etc sysconfig network hyphen scripts. Here all the configurations related with the network are listed down. So let's start the configuration. I'll use Vim. Vim is my favorite editor. So if cfg bond 0, insert mode. First we will add a device equal to bond 0, then IP ADDR equal to, what I'll do, I'll copy the whole configuration instead of typing. Here I have copied, so I'll describe it. Device equal to bond 0, this is the name of the bond. We can have multiple bonds, but primarily we keep bond 0 here. IP address is 192.168.0.11, net mask 255.255.255.0. onboard equal to yes. Onboard equal to yes means in case if we reboot the server, then bond 0 will automatically come up, right? So boot proto equal to none means we are not using any boot protocol, boot P or DSCP. We have two boot protocols available. And user.ctl equal to no means non-root user are not allowed, not permitted to manage this configuration. I mean bond 0. nm underscore controlled equal to no means this is not managed by the network configuration manager. Bonding underscore optius equal to mod 0 means it is used for round robin fashion, I mean as a load balancing. MII mon equal to 1000 means MII stand for media independent interface, mon stand for monitoring equal to 1000 means links connectivity will be monitored in every 1000 milliseconds. I hope you have understand this configuration part. Let's move ahead on ETH1. Again I'll use my notepad. I have already mentioned here. Oh my god, we missed D. Device equal to ETH1. Here Ethernet 1 is used as a slave device for bond 0. Onboard equal to yes, as I said in bond 0 configuration. Onboard equal to yes is used for automatically up when server reboots. Master equal to bond 0. This slave device is part of bond 0. Slave equal to yes because ETH1 is will work as a slave device for bond 0. And either boot proto I have already discussed, user.ctl nm control. Type equal to Ethernet means We are using Ethernet card, not the Wi-Fi devices. We can use two devices, Ethernet or Wi-Fi device. So let's save it. I will move ahead to configure ETH2. Again I will use my notepad. Device 2, device equal to ETH2. What is happening? Device equal to 1. The same thing here, ETH2 is used as a second Ethernet here in ETH2 configuration. Now bonding has been configured. Let's start the services. Service restart bond 0. What is happening? Oh, it is only because I am quite handy in RHCSA. No problem. Network restart. Okay, some host is already using, it says no problem, we'll change it. Here I am using another IP, let's say 20. Start. So all the network interface card including bond 0 successfully has been restarted. Let's check if config. See here our IP up broadcast running master multicast. See bond 0 is up, slave, sorry, we have used ETH1 and ETH2 as a slave device for bond 0. Here slave is also up. Let's verify. We will use cat proc net bonding bond 0. What happened? I was typing something wrong. I'm really sorry. So the bonding, NIC bonding has already been uh, configured. Let's take a duplicate session. We'll check. Duplicate session. Root. Just ping. Copy this. Okay, let's test. Down. ETH1. ETH1 has been down. We can have a look here. Watch. Correct. See, ETH1 is down. Let's bring it up. ETH1 is down, but still ping reply is continuous. Let's bring ETH1. See, now ETH1 is up. Okay, so this is all about the NIC bonding in RHCL6. Thank you for watching my channel. Thank you so much.